Hi, welcome to my YouTube channel. My name is Lincoln Thompson and I'm a mathematics teacher. And what basically inspired me to start this math channel is because based on what is happening now, little or no face-to-face classes, and moving on to CXC for this year 2021, students really need a lot of additional help in order to move through to their exams. So in particular, I upgrade mathematics content to this channel, especially to target the CXC level, because trust me, these students really need a lot of help in this time, because CXC date will not change, everything remains the same. However, the teaching and learning process was severely affected as students have been out of school for several months last year. So I created this channel to help these students to get back on track with what is happening. So as I said, subscribe to the channel, leave your comments, any questions or anything you might have, any videos that you want me to do, just point them out so that I can do the research and then bring the video to you here. Alright, so for this first video, we're going to look in linear inequalities. And the first objective for this video is basically to solve linear inequalities, then to represent these solutions using set notation on the number line and also on a graph. Right, I'm going to explore everything here with in-depth explanation and diagrams so that you can get a solid understanding of what is happening here. Alright, so let's move on. Alright, a linear inequality is like a linear equation, such as y equal 2x plus 1, but it will have an inequality symbol instead of an equal sign. Right, so for example, this equation that was given, y equal 2x plus 1, this is basically an equation because it has an equal sign right here. But if we are speaking of inequalities, it would be something like this: y, let me change this color, less than 2x plus 1. And please note that we're going to be working with 4 inequality symbols. So in this case we have less than, we can also have greater than, less than or equal to, or also greater than or equal to. And we'll explore all these inequalities in details along with showing examples that are associated with each of them. And if you should look in the table right here, starting with the less than, let me clear this up, less distraction, starting with the less than symbol, right, which you have here, it reads is less than. Right, commonly used phrases are fewer than and under. So if I should say x less than 2, I am speaking of all the values of x that are less than 2. Right? However, it does not include 2. And it might be a little tempting to involve 2, but 2 is not included, because once we say x less than a particular value, then it is everything below, under, or fewer than that value. So 2 would not be included here. Right? And for the less than or equal to aspect of it, right? So if we say x is less than or equal to 3, for this one we are speaking of all the values that are less than 3, similarly to the values that are less than 2, and also 3, because this equal portion right here speaks to the 3, where x is equal to 3. And you can look at it this way: this less than or equal to symbol is basically representing less than and also the equal sign. But what happens for the symbol is that they actually merge the two symbols to form less than or equal to. So for the less than part, so for the equal part, x would be equal to 3, but x is also less than 3 for the less than portion. Hence the symbol less than or equal to 3. Right? So we'll explore this in more details as we move along. And for this part that says is greater than, right? So if we should have x is greater than, so for instance, 5. These are all the x values that are more than 5. So more than or over. And once something is over something else, then it is not on it. It is basically above. Right? So x greater than 5 are actually the values of x that are greater than 5. Not inclusive of 5. Right? And for this portion now where we have greater than or equal to, as it reads here, this means at least, no less than, or from. Right? So x greater than or equal to, let's say 7. So this would be all the values that are greater than 7. That would suffice for the greater than portion, and also 7 because it has an equal portion in it as well. And similarly to how we broke down these two signs, it's the same thing for the greater than or equal to. It comprises of a greater than symbol and also an equal symbol. So they merge the two of them together to form greater than or equal to. And we'll do examples to help you better understand that. Alright, let's look at how to solve linear inequalities. But before we jump into that, let's do a little refresher and move back to when we used to solve linear equations. Remember, previously we said that linear inequalities and linear equations are similar. However, the symbols that we have, in this case, we have an equal sign for each of these. But in the inequalities, you wouldn't have an equal sign. You would either have less than, greater than, less than or equal to, or greater than or equal to. So before we move into solving linear inequalities, we're going to explore or do a little revision of how to solve linear equations. Alright, so get rid of this and those, and we are ready. So let's look at number 1. Right, that says 2x plus 5 equal 9. Right, so the first thing you ask yourself, what does it mean when they ask you to solve an equation? Right, in this case, solving this equation would mean that you should find a value for x. So x is a certain value, and whatever that value is, if you should substitute it in the equation where x is and carry out this operation, then you would end up with 9. So in this case, that value would make the equation true. Right? So let's explore how we'll actually go about solving for this. Alright, let me write that again. So 2x plus 5 equal 9. First example. Alright, how you can look at this is you're going to try and isolate x. If you can get x equal to something, then we would be well on our way to solving for x. So we need to think of how to remove 5 and how to remove 2. Remember, remove 2 and not 2x. Because once you can keep x by itself, then that would be good for us. So in this case, we will have 2x, have 2x plus 5. Now how can we remove our 5? Yeah man, if we subtract 5, then we remove the 5, right? Simple as that. Equal. But on the premise of equation balancing, whatever you do to one side of the equation, you have to do it to the other side. So we subtracted 5 on the left hand side, so we're going to subtract 5 on the right hand side as well, in order to keep the equation balanced. So these 5's will cancel. So we are left with 2x equal 9 minus 5, 4. Good. So we have removed the 5, the positive 5. Now, next thing, how can we remove 2 in order to get x by itself? So if you notice in this previous step, we had a positive 5, and we carried out the opposite operation, which was to subtract 5, right? So we're adding 5 here, so we subtract 5 here to get rid of it, and we do it to the other side as well. What this is saying is you perform the opposite operation, because subtraction, the opposite for addition. So for this case, where the 2 and the x are being multiplied, we actually carry out a division to get rid of the 2. Division, opposite of multiplication. And whatever we do to one side, we do it to the other side as well. So we divide by 2 on both sides. These 2 will cancel, so we are left with x equal 2 into 2, 1, 2 into 4, 2, x is equal to 2. And that is our solution for x. But for this first one, I just want to point out something. So for example, I go back to the original equation, which was 2x plus 5 equal 9. And my value of x here is actually 2. So for example, I should substitute 2 in this equation. So if I say 2, our value of x is 2. Let's put back 2 right here and see what happens. Plus 5 equal 9, right? 2 times 2, 4, plus 5 equals 9. 4 plus 5, 9 equals 9, which is a true mathematical statement. So as we said previously, the value of x would make the equation true, as in this case where x is 2, we substitute 2 in the original equation and we reach our point where we had 9 is equal to 9, which is mathematically correct, right? So that's it for the first example, and I'll work the next 3 so you can have a solid understanding of what is happening here.